discuss electrical potential at a point P in an external electric field of a source charge Q, right? Today we are going to discuss electrostatic potential energy, right? We refer it as electrical potential energy also, or potential energy, right? Okay, so let me revise in a few what we discussed yesterday. Yesterday we discussed that how electrical potential is defined first. So definition was how we define electrical potential at a point P. So again, understand, if we have a source charge Q, if we bring a test charge from infinite distance to a given point, which must be in the electrical field region of the source charge, then work needed to done against the electrical field, you getting my point? Then work done will store in terms of electrical potential at the site, at the point, right? Okay, now what we did, this is the procedure I mentioned in the short, right? dW is equal to integration, F external is what? Force needed to bring us to a test charge from infinite to a given point into small displacement. We divide entire distance in a small displacement elements, say dr, right? Okay, so total work done dW is equal to, total work done is equal to what? How many total work in all the displacement? Infinite, many, right? So we combine all and take integration from infinite to point P, and this is what we got. Okay, now by definition we know this work done will store in terms of electrical potential at the point P, so we indicate it as Vp is equal to W. This is the same. Here we use F external is equal to minus F, then we get this negative sign over here, right? We discussed that yesterday. Okay, now we know that potential at a single point make no sense in physics, right? So we have to find out potential difference between two points, right? We have to compare potential of one point to the other point. So this is what the potential difference, right? So let some other point R is also present in electric field there, right? So we find out potential at a point R, right? And then take a difference of these 2 points, right? So potential difference del P is equal to say Pt minus Pr, and it is given by integration P to R Fe into dr. Do you get my point? And what's the unit of a potential? Is indicated as a volt, and other unit is joule per coulomb. So it's also indicated as like this, J C minus 1, right? Dimension formula, M1 L2 T minus 3 A minus 1, right? This is the dimension formula you can find out from here. And voltage is also related to the current. We will study it in the third chapter, current electricity, right? Okay, now this is the point to make, right? What we doing here? What is the force between two charges? Which charges we use? Capital Q and small q somewhere here. And the distance at the end point is R, right? The force exerted between these two charges is kq upon r square, right? Okay, let q is the test charge first. So our condition is test charge must have a value 1 unit. So we use 1 unit there. That means this force is removed between these two particles, right? And the agency which is present in between is only the electrical field by the source charge, right? So this electric field will converted into force is converted into electrical field. E is equal to kq upon r square. So similar, if we use q is equal to 1 unit in our equation, there F is equal to, if we use this ratio and we use q is equal to 1, we discussed yesterday, then instead of F you can use electrical field here. So the character or the other relation of a potential is also given by integration of P to R. Instead of force, we use electrical field here into here. Why this is? Because in the force here, in the force unit value of a test charge is what? 1 unit. Are you guys clear about it? Okay. Now take this to our concept today, electrostatical potential or electric potential. Okay, what is the difference between these two things, right? Focus here and try to understand. Similar thing, here it is source charge Q. Let P is under the area or is inside the electrical field range. Let this point is infinite we bring Q from infinite to point P. We bring Q from infinite to P. Then work done against the electrical force will be stored in terms of electrical potential energy at the point of discharge. You get my point? So what is the difference between electrical potential and electrical potential energy is that in the electrical potential we use Q is equal to 1 unit. 1 unit, right? Or unit positive charge. But this is not mandatory in a practical way that you have all the time test charge having a value 1 unit or it is 1 positive charge, unit positive charge, right? No. So in the practical, sometimes we have Q having some finite value, anything, 1 coulomb, 2 coulomb, 3 coulomb, whatever, right? What if this test charge have some value? Then if you bring this charge Q, this is not 1 unit now, remember one thing, this is not 1 unit, right? This is the simply Q. When you bring Q from infinite to point P, then work will be done against the electrical field. You get my point? Against the electrical force of the source charge. This work done is now stored in terms of potential of the charge Q at the point P. So you get my point, right? That means when you brought this Q closer and closer and closer to the source charge Q, the repulsion between these two charges will be increasing gradually. Why? Because the distance is decreasing. Repulsion is increasing, that means the capacity to do work is stored inside this test charge. Can you get my point? That means it increases its potential energy as it moves closer to the source charge. You get my point? Okay. So the definition, what difference is? Yesterday we discussed work required to be done against the electrical field in bringing. Here we use unit positive charge, but here now we use a charge from infinite distance to the given point in electric field is called the electrostatic potential energy of that charge. You get my point? That means electrical potential is associated with the position, with the location, with the site of the point. But electrical potential energy is associated with the charge at some point. You get my point, right? For example, let you take charge at here only. તમે charge ને move કરાઈને suppose અહીંયા જ લાવો છો. Say this point is R. The distance between these 2 points, source and the point at where you take this test charge, you get it? Is relatively greater. So potential energy of the charge will be relatively lower, right? Now if you take this charge at a point P which is relatively closer to the source charge, hence potential energy of the test charge Q is greater. You get my point? જેટલું ડિસ્ટન્સ ઓછું હશે એટલી પોટેન્શિયલ એનર્જી એ ચાર્જની વધારે છે. કેમ? બીકોઝ રિપલ્શન વધારે લાગતું છે in between. You get my point? Okay. Now this is the explanation, right? Okay. If a charge Q move against the electrical field by applying an external field which is mandatory, then work is said to be done. We know this work done by the external force is stored in terms of potential energy of that charge, right? Okay. By definition, what is the difference between potential and potential energy? In the potential, Q is equal to 1. There was Q is equal to 1. But in the potential energy, Q is not equal to 1, but Q is equal to Q itself. Q coulomb, for example. You are getting the point, right? So in both these cases, the difference is only Q. And then we use Q is equal to 1. Here we use Q is equal to Q itself. Means some value, finite value. You get my point? That means we have to add Q in the formula of potential there, right? જે આપણે અહીંયા Fe is equal to ના વેલ્યુમાં કે Q upon R square માં Q ની વેલ્યુ જે 1 મૂકતા હતા ને આપણે, right? એ હવે Q નહીં રહે. Q is equal to 1 નહીં રહે. There must be Q is equal to Q itself. You getting my point? So when you take a Q is equal to Q, you have to use this entire formula here. You getting my point? So what is the difference? That electrical potential energy U of a charge Q at a point P is equal to electrical potential at a point P multi that charge. પહેલા જ્યારે પોટેન્શિયલ ફાઇન્ડ કરતા હતા ત્યારે ત્યાં q ની વેલ્યુ તમે 1 મૂકતા હતા એટલે પોટેન્શિયલ થતો હતો બટ નાઉ q છે q ની વેલ્યુ q જ છે, right? So now this work done is called electrical potential energy. Are you getting my point? Okay, that means we have to multiply this potential multi the charge which is moved from infinite to the point, right? So energy is indicated as U. Electrical potential energy is indicated as U. U is equal to Q multi potential at the site, right? Q multi potential at the site. What is the potential at the point P? So we know it is indicated as Vp. Which charge you bring from infinite to the point P is the charge Q, right? So multi this charge by the potential at this side. This gives you potential energy at the point UP. You get my point? So potential energy UP is equal to Q charge Q multi potential at the point VP. Got it? Okay. Now UP is equal to, what is VP? We know VP is equal to integration of what? E into dr, as we discussed here. Integration E into dr, right? So what we have to multiply to convert this potential into what? We have to multiply just it by Q, right? So Q into integration E into dr. This is what the potential energy at the point P. Are you getting my point? Now potential energy difference between point P and R. Let such a point R is given somewhere here. Then how we find potential energy at the point R? In the similar manner, UR is equal to Q into integration E into dr. Now take the difference, right? So UT minus UR is equal to QVP. So what should be potential at the point R? QVR. You getting my point, right? So UP minus UR is equal to QVP minus UR. What is common here? Charge Q. Take it out. Q into VP minus VR is equal to Q into this V is shows the difference between the two charges. Simply we can indicate it as delta V or V, whatever you want. You getting my point? So this is the potential difference which stands for the difference VP and VR. You getting my point? So this is what the potential energy. Again, make sure potential is related, is involved with the position. कोई पण point ने कोई पण position ने potential होय. So we call it as potential at the point. But potential energy is associated with the charge which you bring from infinite to point. You can remember that means you have to multiply that charge with the potential at the point. જ્યાં તમે ફિક્સ કરો છો એને. You getting my point? So આ ચાર્જ ને આપણે અહીંયા લાયા ક્યાં તો કે પોઈન્ટ P આગળ, તો ત્યાંનો પોટેન્શિયલ કેટલો છે? This is Vp. So what we have to do to find out potential energy? We multiply the potential at the site and the charge which you take from infinite to this point. So this is a Q. So Vp multi that charge is called the potential energy, and it will be stored in terms of potential energy of the charge at this point. Are you guys clear about it? Okay, have a good day.